Hello and welcome to this quick take video focusing on the messages, reports, and log files produced by the Vivado Integrated Design Environment. The Vivado Integrated Design Environment is a new and powerful tool for the creation, analysis, and validation of designs. It provides rich messaging and reporting capabilities. There's often cross-probe support to source files or between schematic and other views. I will review how messages are organized and displayed in the user interface. I will demonstrate some of the main reporting commands. Some of these are produced automatically in a project flow. You can manually create reports throughout the flows as well, either in a non-project or project mode. I will also cover the log and journal files that are always created. Here we have the Vivado Integrated Design Environment with a synthesized design open. Vivado provides many helpful messages that are grouped by severity. In the Project Summary tab, we can quickly see a summary of the messages produced up to this point. If we hover over these links, we can see that it says it'll show error and critical message warnings in the messages window. If I hover over the warnings, it says it'll show the warnings and error messages. Let's click on the critical warning. We can see now that the message window has been activated and is filtered according to the severity that we selected, which was just critical warnings. I can elect to show all messages if I like. I have various options. I can collapse or expand all the messages. I can group by file. So all the messages for a particular file are grouped by that file name. And I can group by message ID. Now let's go back to just that one critical warning. We see here it says that we have a constraint, the set input delay, that's missing an object, and that we need to make sure that this is corrected. So what I can do is I can just click on this link. It opens up the file that's being referenced and takes me to the line number with the problem. Looking here, I see, oh, I made a spelling mistake. That should have an E there. So I can do that and save that constraint. It shows now that the design is out of date because I've modified one of my constraints. Looking at some of the other message types, I also see that there is other forms of linking available. For example here, I have a warning message that says a parameter declaration becomes local in the command parse with formal parameter declaration list. Again, I can click on this link. It'll open the file in question and take me to the line number. This just gives you a quick summary of the messaging that's provided and the cross-probing support that is available in the Vivado IDE. The Vivado Integrated Design Environment provides many reporting commands. For details, you can reference the Vivado Design Suite Tickle Command Reference Guide and the other Vivado user guides. The built-in help is very useful. This is accessed via the Tickle console. You can get help on a specific command or use wildcards to learn about all the reporting commands available. Let's start with Report Timing Summary, as it is the most comprehensive and important reporting command. It includes information provided by other reporting commands, such as report clocks and report clock interaction. Vivado provides a helpful wizard for the main reporting commands. They provide a convenient interface for exposing and configuring reporting options. For the Report Timing Summary command, we see there's the Main Options tab, there's an Advanced Options tab, and there's a Timer Setting tab. The tickle command that's ultimately executed is also shown in many cases, and this can be edited if desired. Let's go ahead and stick with these default options and press OK to launch this report. Timing is performed on the entire design, and the Design Time Summary section is opened for the timing run in a new tab. The report is organized by section, enabling quick navigation to the information desired. We can see here that we have setup violations. We see the worst negative slack, the total negative slack, and the number of failing endpoints. Let's say we wanted to go and get details on one of these failing timing paths. We could explore down to the clock group that has the failing paths and select them. We see a list of the timing report. Gives information about the total delay, the logic delay, the source and destination clocks. To get a more detailed list of information on one of these timing paths, double-click on it. The detailed timing report is organized in 4 sections: the summary, the source clock path, the data path, and the destination clock path. Let's go over each of these in turn. The summary gives the slack, the source and destination cells in this timing path, the path group, the requirement, the data path delay, and the logic levels. The source clock path gives the information about the launching clock of this timing path, the delay to the point at which this clock launches the data. The next section is the data path delay. This is just the delay through logic for this timing path. The final section is the destination clock path. This is the delay path for the clock that captures this signal in this timing path. Going back to the sections, we can see that there's general information, which is when the report was run, some of the project details like the device and the speed grade, and the command that was run for this report. Another section is the timer settings that were used for this particular run. The clock summary is the same information that you would see in a report clocks command. The check timing section is the results of running a check timing command. This command checks for problems that might exist in timing, and everything that's listed you should take a look at and see if there's anything that you need to do. This might include creating new constraints or modifying existing constraints. The next section is the inter-clock paths. This is giving timing paths within the same clock domain, organized by clock. The next section is the inter-clock paths. So these are the timing paths that cross clock domains. The rest of this has path groups and some unconstrained paths. These are paths that you might need to constrain or that are lacking certain constraints. Now, the report timing summary command is automatically generated for you in the text form. So if you go to the Reports tab, and you go down into the Route Design section, you can see that there's a timing summary report listed. If you double-click on this, it'll open up, and a text version of the information I just showed you is provided. This is kept in the project and is available every time you implement the design. Now let's move on to some other reporting commands. Now let's run report clock interaction to generate a clock interaction matrix. As before, a wizard opens, which allows me to explore and configure the various options for this command. As you see, the actual tickle command that's executed is also shown. And again, I can edit this directly if I am very familiar with the command. Let's go ahead and just launch the default by pressing OK. This shows an interaction of the clocks in our design. We see on the x-axis and the y-axis the clocks that exist in our design and how they interact. A black box means there's no paths between those clock domains. A green box means that there are paths that exist and that they're fully constrained. If there were any red boxes, that would indicate that there were false paths between those clock domains. A yellow box means that there's partial false paths, meaning that only some of the paths between these two clocks has a false path. We see this is from the launching clock, clock out 1, the receiving clock, virtual clock. Below, we see a table of the same information with more detail. We see the launching clock, the receiving clock, and the worst negative slacks. And if we go down, we see the same worst negative slack we saw in the report timing summary command, and the same total negative slack as expected. Now, I can do things from this point. I can right-click and say, let's report timing. Let's get more details on this timing path. So let's select that. The report timing command wizard pops up. Again, this gives us the ability to explore and configure various options for this command. It's already populated with pretty good defaults. So let's just go ahead and say OK, and this will generate the 10 worst timing reports for this clock-to-clock group. Here are the 10 setup paths that are failing. Again, I can select them. I can double click to get more details. This is the same information that we saw in the report timing summary. Other options are the ability to actually create constraints dynamically. For instance, let's say that this is actually a false path that I just didn't constrain correctly. I can immediately here select to create a clock group or to create a set false path directly from that list. The set clock groups will pop up and I'm able to configure it. I can call the group. It's already populated for me based on information from the table. This is very useful and quite powerful. Let's move to another command. Let's look at some other reporting commands. As you can see in the Flow Navigator, we have report DRCs, report noise, report utilization, and report power. Now, most of these reports are automatically generated for us in text form. So if we go to the reports window and scroll down, we can see in the route design section that a power report is performed and status is produced. In the place design, we have a clock utilization report and a utilization report. Let's go ahead and launch the report DRC. This allows us to select which DRCs we want to perform. We can name a result tab and actually output to a file if we wish to. Let's go press OK. DRCs are performed, and we can see the design rule checks listed here. We see any violators. We can collapse. We can see where the violations occurred in the placer or in the routing stage. If there was a lot of messages here, I could opt to turn off warning and information messages so that I only saw the critical messages. Now let's go ahead and launch a report utilization. I can give a name for the tab. I can again export to a file. Let's go ahead and just do it within the UI. A utilization report is produced. It's organized by category. So let's say I want to look at my clocking resources. It's populated based upon the design. So it only shows things that I'm actually using. So since I have some buff Gs in there, it's giving me the utilization of those. And it gives me the hierarchy of the design listing where these utilizations occur. I can see here by selecting the MMCM that I'm using one of my MMCMs. It's being used in ClockGen I0 cell. Now let's do a report power. Report power wizard provides, again, exposure to all the options that are available for this command. It's a big command. It has a lot of options. So it's nice to have it in a graphical form that I can go and edit these things. I can, again, output to a text file or output to an XBE file. I can select options here. Again, the options are usually pretty decent by default. So unless you have more specific information, it's a good starting place to just run with the defaults. So let's hit run. Power analysis is performed. And when completed, I can double click to see a nice graphical view of my power report. Again, there's a summary, gives information about the summary, the breakdown in terms of I/O, the core dynamic or the device static. Where's my power coming from, my utilization coming from? I can look at the settings, which will summarize all the settings for this particular report. I can look at my power supply for this chip. Again, I can look at the utilization details, so I can look at hierarchically, so listing the whole design in a hierarchy manner. I can see where the power utilization is being used. Not surprising, it looks like the clock generator is the larger consumer of power. I can break it down by clocks, IOs, signals, logic cells, the BRAMs, and the MMCMs in the design. The Vivado Design Suite always produces a log and journal text file, both for a non-project and project flow. The log file contains everything that the Vivado processes produce, such as all the tickle commands and the results, and all the messages that are produced. The journal file contains all the tickle commands that were processed. This is a good place to start with the creation of batch flow scripts. The location of these files is in one of two places. On Linux and on Windows, when run from the command line, they are in the directory that Vivado was launched from. On Windows, when launching from the icon, they're in the user, app data, roaming, Xilinx, Vivado directory. The log and journal files are quickly available from within the IDE. By going to File, I can open the log file. This way I don't have to worry where the file was stored on disk. If I select that, the log file is opened up and I can look at it. This is the same with the journal file. As you can see, the journal file contains all the commands that have been run in this particular session. This is a good place to start if I want to write scripts based upon the actions that I just performed. So now I can cut and paste various commands that I used and put them in a Tickle script, or if I was doing constraining, I can copy and paste constraints into my constraint file. To summarize, I have demonstrated how the Vivado Integrated Design Environment provides 5 levels of message severity, cross-probing support from messages and reports to the source files and to the design database. There are typically 2 versions of a reporting command: a graphical one that provides cross-probing support, and a text-based one that is produced from the Tickle console. I have also covered the log and journal files that are always produced and how to easily view them from within the design environment. Thank you for your time. I hope you found this demo useful. For more information, please see the other quick take videos and the Vivado user guides. Goodbye.